Okay, let's go to page 592. Okay, reflection matrix. You can find the image of the polygon reflected in the x-axis or y-axis using the matrix multiplication. Write the reflection matrix to the left of the polygon matrix. Okay, so and it says then multiply. Notice because the matrix multiplication is not commutative, the order of the matrices in your product is important. So again, do not. So matrix is not commutative, means you cannot switch the order. Okay, so the order is very important. The reflection matrix must be the first, followed by the polygon matrix. Okay, so again, so reflection matrix, reflection in the x-axis. Okay, so it's 1, 0, 0, negative 1. Okay, so when you reflect over, so that it goes over here. Now, if you reflect over the y-axis, it's negative 1 over here. So see the difference. Okay, so make sure you have these notes. Okay, again for your notebook. So make sure you have this in your notebook. Okay, so again, if you're going to reflect over the x-axis, you're going to have 1, 0, 0, negative 1. If you're going to reflect over the y-axis, you're going to get negative 1, 0, 0, 1. Okay, so now you're going to go to example 5. Use matrix multiplication to reflect a polygon. Okay, so the vertices of triangle DEF would be D is 1, 2, so that's your point 1. See the point 1, so it'd be 1, 2, so it'd be x, y, right? X coordinate, y coordinate. Okay, and so again, so this is your x, this is your y. Okay, and now point E is 3, 3, right? Point E is 3, 3. Point F is 4, 0. Okay. Now you're going to reflect over the y-axis. Okay. Remember, when you reflect over the y-axis like this, right? So here's your y-axis. So when you reflect over the y-axis, the x becomes negative, right? X become opposite. The y stay the same. So that's why you see this is your x and the y, right? So x becomes opposite. The y stay the same. Okay, now you see the reason for that. Okay, now if you reflect over the x-axis like this one here, if you reflect, right, when you reflect over, the x stay the same. See the x, this is your x, the x stay the same, but the y becomes opposite, right? So y becomes negative. So that's why y, see that's your x, that's your y. So x stay the same, y becomes negative 1. Okay. Okay, so now you're going to multiply and do like what we did before. Okay, so you're going to get negative 1 plus 0 give you negative 1. Okay, so that's your first row, first column. Then you go to first row, second column. So you're going to get negative 3, okay, plus 0, okay, will give you negative 3. Then you go first row, third column. So it'd be negative 4, okay, plus 0 will give you negative 4. Okay, once you're done with the first column, first row, you go to second row. So you go second row, first column. So you're going to get 0 plus 2 give you 2. Then you go second row, second column. So you're going to get 0 plus 3, right? So 0 plus 3 will give you 3. Then you go second row, third column. So you're going to get 0 plus 0 give you 0. So that's how you get D prime, E prime, F prime. And so if you plot these, you're going to get negative 1, 2. See that? So this one, you're going to get negative 3, 3, get the E prime. The F prime would be negative 4, 0. Okay? So here's another way of using the matrix. Okay? Now, it seems more complicated to do it this way, but there's a reason for that. Right now, they just give you using the easy problem, easy situation to practice with matrix. But when the problem gets more complicated, the matrix becomes more advantageous. Right now, it's kind of disadvantaged because it's kind of complicated. It's easy if you just flip and just count the square, right? So if it is 1, 2, 3, 4, so you just go 1, 2, 3, 4 to get F prime. This one, you go 1, 2, so you go 1, 2, right? Or you can just slide it over. See, this 1 square, so you go 1 square this way. This one has 3 squares, so you go 3 square this way. So with an easy problem, it's easier to just do it by visual inspection and do that instead of doing the matrix. But the purpose of doing the matrix, they use the easy point for you to practice with your matrix. Okay, so that way when you get complicated problem, it will be all good. Okay, because this only works for 2 dimension. But what happens if I got 3-dimensional, 4-dimensional, 5-dimensional? Okay, then this is going to be difficult to do it this way. So you have to use matrix. So matrix is for like a higher dimension for more complicated problem. Okay, but again, they use an easy problem for you to practice how to manipulate your matrices. Okay.